Hello, we are going to go over lesson 1.4 rational numbers for the grade 9 academic course here. Example 1. Place the following rational numbers on the number line. So here's the number line. You see the integers are listed. This is a real number line because you can still fill out the spaces between 0 to 1, for example. Okay, or the decimal. So the first number is negative 7.5 degrees Celsius. So from 0, you're going to go to the left because it's in the negative. And 7.5 is right between negative 7 and negative 8. Here we go. B, 3.5 degrees Celsius. This is positive, so let's go to 3. 3.5 is slightly greater than 3, so halfway between 3 and 4. C, 2.7. Go to the right. 1, 2. 0.7 is closer to 3 than 2, so you'll end up somewhere here. D, you got a number negative 8.2. Starting from 0, go left to 8. Well, you got to go a little further down, so it's right there. That's negative 8.2. And then E, you have an improper fraction, negative 7 over 2. It may help us to visualize this better if we convert this improper fraction back to mixed fraction. So there are 3 and 1/2 units in that. So negative 3.5 is right there. Do the same thing for F, 9 over 4, or 2 1/4, or some of you may prefer the decimal form, which is 2.25. So it's right there. Example 2. Which of the following are the same? It may be difficult to see all these fractions with the slashes, so we're going to turn them into a more vertical, the straight column form of writing fractions. And then if I see one negative sign beside a fraction, technically I am talking about a negative value of 2 over 5. If the negative sign appears in the denominator, it doesn't change the fact that this is a negative number. So I still have negative 2 over 5. And then a negative sign beside the fraction line, of course, is negative of 2 over 5. So that means the first 3 terms here are the same. The next fraction, well, it's 5 over negative 2. So this is the flipped version, or more properly, we call this the reciprocal of 2 over 5 negative, or negative 2 over 5. So it looks like that. The next fraction, we have negative 5 over negative 2. The rules of integer tells us if I have a negative number over a negative number, the two negative signs simplify into positive. So you have 5 over 2. And the last fraction is also 5 over 2, so I can conclude that the last two fractions are the same. Which of these two numbers is greater? You can either compare them by writing them as equivalent as fractions with the same denominator, so the lowest common denominator, or simply converting them into decimals. When you convert a fraction into decimal, 3 over 7, for example, you can use a calculator and divide 3 by 7. So you get negative 1.4285. How about negative 1 and 4 over 9? Well, we know it's going to be negative 1 point something. So 4 divided by 9 on the calculator gives you 4, 4, 4, 4, 4, 4. So this is negative 1.4 repeating. On the number line, which number is closer to 0? Well, the less negative number will be closer to 0. Therefore, negative 1 over 3, 1 and 3 over 7 is greater than negative 1 and 4 over 9. I'm going to post a chart from Ms. Kuhn's lesson so that you can compare the different number sets. So leave this alone for now. And then rename as a quotient of two integers. So rational numbers can be written as a quotient of two integers. So when you have 3 and 1/2, the rule of thumb is how many halves are there? Well, there are 3 halves. So 3 wholes that are divided by 2, so you double that. So you get 6 pieces plus 1 half, so that's 7 halves. So 7 over 2. The same goes here. It's a negative number, leave the negative sign on the outside. To find the new numerator, you do 2 times 5 plus 2. You get 12 over 5. So it's negative 12 over 5. When you write fractions as decimals, you divide the numerator by the denominator. So 1 over 3, take out your calculator, divide 1 by 3. You get 0.3 repeating. For 2 1/4, it's going to be 2 point, and 1/4 is that famous fraction that can turn into 0.25. And a negative 3.5 will become negative 3.5. Example 6, write as a quotient of integers. So here we're going to turn decimal numbers into integers. To turn decimals back to fractions, you will have to identify the last decimal place. So in negative 0.24, your rightmost decimal place is the 100th place. So you can place 24 over 100. And because it's negative, make sure you have a negative sign on the left. And then 24 over 100 can be reduced or simplified. Divide both numbers by 4. You will have 6 over 25. So take a look at 2.375. 2 is a whole, so you can write it as a side in a mixed fraction first. And then 375 in the third decimal place. This is the same as the 1000th place. So you make 375 over 1000. You can simplify this fraction into 3 over 8. However, because the question says write as a quotient of integers, so it doesn't say write as a fraction. So in order to write this as a quotient of integers, we really mean that write it as an improper fraction. So you have to convert the mixed fraction into an improper. So 2 times 8 is 16, plus 3, that's 19, 19 over 8. Part C, you have negative 9.52. 2 is in the 100th place, so 52 over 100 will take care of the decimal part, and then reduce that by 4. You get 13 over 25. Turn this improper fraction, mixed fraction into an improper fraction. 9 times 25 plus 13, that's 238. So negative 9.52 is equal to negative 238 over 25. That's the end of lesson 1.4. You may now move on to work on your classwork/homework on page 45, number 1 to 10. And don't forget, go to the website and take a look at the number set chart from Ms. Kuhn's lesson.